Okay? Let's have a go at deriving the formula for variance, though. Okay? So, are you happy that x is effectively made up of lots of little throws? Okay, so think of it. I'm just basically throwing that beanbag 5 times. Okay, the way which I can think of this, okay, so x, which at the moment is distributed binomially with n trials, and each trial has a probability of success of p. Okay, what I could think is that x is effectively made up of lots of single trials. So think about it. I treated one go as throwing the beanbag 5 times. Okay? What I could do instead is think about x as one throw, and then another throw, and then another throw, and then another throw. So lots of single trial events. Is that okay? Yeah? So what I could do is treat it as yi, so y1, plus y2, plus y3, plus y4, plus y5. Okay, so in other words, y is just a single trial. Y is just a single trial. So y, whatever it is, first, second, third, fourth, fifth row, whatever it is going to be binomially distributed, but this time with a trial of 1 and still the same probability of success. Is this okay? Do you follow that? So literally I'm just saying just treat one throw separately. Okay, so x is made up of 5 throws, so just look at each throw separately. I'm just using I to represent either the first throw, second throw, third throw, or fifth throw, or fourth throw. Is that okay? Right. So n in this case is representing, well, okay, the number of trials. Okay, so in my example, I'll go use this example. Okay, in my example, okay, I'm saying I'm going to throw it 5 times. Okay. What I'm now doing is saying, instead of just treating that as a whole, I'm going to separate it into individual throws. So each throw is only going to be 1, isn't it? Because it's just I only throw it once. So this is representing one throw. So the number of trials for one throw is 1.
So if it's 1, 2, it's still 3 and 1.
Exactly. Oh. Yes. So this just represents one particular one. This represents a binomial distribution where you're only doing it once. So remember, x is represented with 5 trials, so 5 throws, right? But now what I'm going to do is break x into individual trials, so 5 individual trials. And each trial is going to have a probability of, n equals 1. Is that okay? Yeah? So just think, yi is just one throw. So because it's one throw, I'm going to have n equals 1. Okay? Now have a think, right? What would the probability, so for yi, okay, what would the probability that y equals 0 be? So what's the probability of getting no successes? So I only throw it once, what's the probability it doesn't land? Well, okay, in this case it's 0.4, but if I just use it generally as p, what's it going to be? 1 minus p, exactly. Or if I prefer, what could I also call that? Q, fantastic. What's the probability? So I throw it once, what's the probability that it lands? It's just going to be p. Is that okay? Right. Now just remind me, what is the formula for variance? So I'll do it with y actually. What's the formula for variance? Do it in terms of expectation for me. So what's the variance of a random variable? Yeah, I think you're thinking. It's going to be expectation of y squared minus the expectation of y all squared. Do you remember that? Yeah. Okay. Where the expectation of something is going to be the sum of each outcome squared times by their associated probability. Okay. And actually, we've already got this up here. Okay, we've already got this up here. So minus the expectation of y all squared. Is that okay? Yeah, okay, good. So let's think about this. Right? So I want the expectation of y squared. So I'm just going to deal with this bit first. What's the expectation of y squared going to be? Well, what I'm literally going to do is I'm going to sum together, so the expectation of y squared is literally going to be the sum of each outcome. Remember, there's only 2 outcomes now, 0 successes or 1 successes. So I'm going to sum each outcome, square it, times by its probability. So I'm literally going to say, I'm going to take my first outcome, which is 0, square it, times by associated probability, which is going to be Q. And then add that to the other outcome which I can have, which is 1, square it, and times by associated probability, which is P. Absolutely. Okay? Now, what's the expectation of y going to be? What's the expectation of y? Well, we can treat this quite easily. Okay, so the expectation of y is just going to be the sum of y times by p. Yeah? So in other words, the outcome which I can have is going to be 0 times by associated probability, which is q, 0 times q, plus the other outcome, which is 1 times by associated probability, which is p. Okay? So 0 times q plus 1 times p, last time I checked, that's going to be p. Okay? And let's just quickly check this thing. What's 0 squared times by q plus 1 squared times by p? That's going to be p. Okay? So in other words, what I end up with is this thing, so the variance, let me write it over here, is going to be the expectation of y squared, which is going to be this thing here, going to be p, minus the expectation of y all squared. Well, the expectation of y is p, square it, you get p squared. Or, if I do a little bit of algebra with this, I could say that's p multiplied by 1 minus p. You happy with that? Yeah. So what's 1 minus p again? P times by q. Does that make sense? Now remember, that is just for one trial. That's just for one throw. Okay? So in other words, that's going to be p times q. That's going to be p times q. Does that make sense? Yeah? So let me create a little bit of space. Let me get rid of this. So in other words, x is going to be, or the variance of x is going to be the variance of each of these individual things, okay? Which implies that the variance of x is going to be the variance of y1, which is going to be p times q, right? Plus the variance of y2, which is going to be pq, plus the variance of y3, etc., 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 etc. Okay? So how many times are you going to be adding pq together? N. So there you go, right? So in other words, what I can say up here, let me get rid of that. What I can say up here is that the variance of x is just going to be npq. Okay? But all it basically is, you're just breaking it down into individual trials. Okay? So remember when we threw that beanbag, okay, I threw it 5 times and I said that 5 throws represented x. Well then x is just going to be lots of 5 lots of individual trials. Okay? And you just look at each individual trial separately, just basically a Bernoulli distribution. Okay? And then you can work out from there that it's just NPQ. So please make sure that you follow it in the notes.